Good morning, good afternoon, everyone, and welcome to our webinar, where today we want to show you how to achieve high availability for SAP deployments running on the AWS cloud. My name is Ricardo Casanovas, and with me we have Guillermo Torres and Mauricio Galofre. And before we start, we're going to wait a couple of minutes and have the chance for other people to join. So please wait with us, and we'll get started quickly. Okay, we're going to wait 1 more minute, and we'll get started. Thank you. Okay, so I think we're ready to start. So welcome again, everyone, to our new webinar, where today we want to talk and show you how to achieve high availability for SAP deployments on AWS. As I said before, my name is Ricardo Casanovas, and with me I have Guillermo Torres and Mauricio Galofre, and between the three of us, we will drive you through the webinar today. Before we get started, we'd like to highlight a little bit the purpose of the webinar today. The way AWS Cloud works differs from standard infrastructure or on-premise, and the way SAP Business Suite products have achieved high availability on those environments differs from the architecture of the AWS Cloud. So from Linke, we worked on a high availability solution, especially for the central services instances of SAP to be orchestrated by AWS services. So we will show you how a combination of AWS Lambda, SNS, CloudWatch metrics, and SSM will work together to orchestrate the failover of a central services instance of an SAP system. That, of course, is extendable to other components of the SAP application stack, which we will cover in more detail in this webinar. So before we get into the technical matters, I'd like to do a small introduction about our company before I hand over the talk to my colleagues. So for all of you that are not familiar with us, with Linke, Linke is an AWS Premier partner, AWS Premier consulting partner to hold the SAP competency and the DevOps competency as well. And we're also an SAP partner. We specialize on helping customers run, migrate, deploy, and optimize their SAP workloads on the AWS cloud. And a part of our services, we do have a suite of technology products that help those SAP systems run better when in the AWS cloud. Being this high availability solution, one of those technology products that we develop and offer to our customers. As a company, we are a team of 75 people, most of them a team of engineers holding both the SAP and the AWS technical knowledge. We were born as a company in 2010, and we've had a steady growth since then as a company. And we'd like to highlight that just in 2018 we have a slightly over 60% growth in revenues. And of course, we expect that to continue to be like that in the future. Some KPIs about our company. We are the only non-global system integrator to have the SAP Premier Partner, the SAP Competency, MB, and AWS Premier Partner. Just in 2018, we delivered more than 52 SAP migrations to AWS. We work with customers in over 9 countries, mainly in the EMEA region. We run and manage more than 140 SAP productive instances on AWS. And our team holds more than 100 SAP and AWS technical certifications of different levels. And our suite of products today is formed by 5 different and unique products that help improve SAP workloads on the AWS cloud. You can access through our website and through AWS site as well, and see our public case studies for a few subset of our customers, where they share their experience moving their SAP workloads into AWS and how they have optimized their cloud spend and their agility using AWS with our help. So, ended up here the introduction of our company. I will hand over the presentation to my colleague Guillermo, and he'll drive you back.
Good afternoon, everyone. My name is Guillermo Torres, and I will try to explain to you our new proposed solution for high availability infrastructures in AWS Cloud. Achieving business continuity is a major concern for modern organizations. Downtime can cause significant financial impact and in some cases irrecoverable data loss. And the solution to avoid in-service disruption and unplanned downtime is employing a high availability configuration or infrastructure. Sorry. Whether you choose to house your own IT infrastructure or opt for a hosted solution in a data center or a public cloud, high availability must be the first thing to consider when setting up your IT environment. A highly available infrastructure has the following traits: hardware redundancy, software and application redundancy, data redundancy, and the single points of failure eliminated. In an SAP landscape, we can state the following list as the key components to be managed by the high availability solution. So these are the central services, the main service for SAP communications. It has 2 components: message server, that is the communication channel between the application servers and the SAP logon and the end users, and in queue server, that is the log manager. The application servers is where the work happens. It's composed by core processes, user sessions, and batch jobs, and many more things. The database, the data consistency of the database, and a minimum LTO and RPO are key values for businesses. There are also the shared directories because file systems as SAP MNT and user SAP transport directory should be available at any time from any server. And also, and not less important, is the connectivity. Users, the connectivity from the SAP clients to SAP servers should be ensured at any time. How can we achieve high availability solutions in the cloud today? So we can use operating system native tools like Windows Cluster, Microsoft Cluster, or User Cluster, and any other kind of clusters. One of the keys is that you don't need any additional software to be installed or to be provided to be able, at least you must install some additional components, but no more. And the consideration for that kind of solution is that you need more resources, like the Microsoft clusters need witnesses to check the health of the cluster. There are some shared resources limitations, as in AWS, the disks, the devices cannot be moved from one instance to the other. And in some cases, there are some license costs attached to them. Third-party solutions. There are proven solutions that have been used in on-premise infrastructures, and now they are moving to the cloud. Considerations for that solutions are they have a license cost. Also, you need some expertise to know how to manage these solutions, and not always they are cloud ready, or they use the power of the cloud services. And lastly, there are some businesses, brave businesses, that they want to develop their customers' application. So they develop an application that is specifically designed for the infrastructure, but it has a cost that in the number of team resources. There are long-time projects, and sometimes you have a lack of documentation in case that your team changes. And so then what is the proposal from Linke? From Linke, we propose a serverless orchestration. Let the AWS services monitor, test, failover, and heal your SAP instances. What are the benefits of that solution? That it's completely serverless. You don't need to install any software in your infrastructure. You don't need to check the health of that services. All AWS services are highly available by default. Being high available by default, there are no single points of failure in the orchestration solution. It is cost efficient because there are no licenses needed. Only having an AWS account, you can use all of these services provided with the solution. It has an easy configuration. You only need to specify which instances do you want to monitor. And as you can see, it's easy deployable using CloudFormation and Terraform templates provided by Linke. What are the building blocks of the AWS services? We have detected the following services that allow us to ensure a reliable, high availability solution. AWS Instance Manager to execute any command, any script within the AWS instances, without having to store that scripts in the server itself. Amazon Elastic File System that ensures an NFS file server high available and durable. Amazon CloudWatch that allows us to monitor the state, the health of the instances, not only the instances, but only the services running on these instances. Amazon Simple Notification Service, that is the one that will be calling the functions to perform the failover and health, and also to inform the user that something has happened in the infrastructure. As I said, Lambda functions, that these will manage any any change in the AWS infrastructure. And for the connectivity part, we have Route 53, that is the DNS service for AWS, that will guarantee that all the DNS resolutions from the SAP clients to the final servers, and elastic load balancing that will manage the network between, again, the SAP clients and the SAP servers. What are the serverless high availability solutions for each part of for each component that we stated before? For the hardware scenario, we will be managing the infrastructure in two different availability zones. It is not serverless by default, but it is transparent for you. Using two different availability zones will guarantee the resilience of your infrastructure, because you can understand an availability zone as a different data center that is completely isolated from the other. So in case of one availability zone is down, the other one will manage all the resources needed for your infrastructure. For the connectivity solution, to be able to guarantee that the communications will be available at all times, we will be using Route 53, that again will handle all the DNS resolution. So if in case of any change will happen in the name part of the name servers or in the application load balancers, it will be transparent for the end users. And also the elastic load balancers that will load the traffic between the client side and SAP. And most important, it will ensure that no traffic is sent through a private instances in case of a failure event. As the web dispatcher and SAP router, they don't have a high availability feature itself, we will be doubling the servers. They are small servers, they don't have any high cost. So we will be storing two different instances in two different availability zones to guarantee that the service is never lost. As the file server, the SAP MMT, the user transport directory, and any other direct file system that should be available from any server will be managed by Elastic File System. That is a system object service that is redundantly stored across multiple availability zones. Each object that is stored in there, it is replicated, so the possibilities of data loss are minimal. The mount targets themselves are designed to be highly available. Each availability zone will have one endpoint for the SAP servers hosted in there to be able to connect to the servers. And in case of the mount point failure, the SAP servers of one availability zone will be able to access the file servers through another endpoint in another availability zone. You don't have to worry about the storage, because you can store up to petabytes of data. And also you can ensure the security with IAM roles, user level roles, and network level rules. Sorry. In the application server scenario, there is no high availability feature that we can use to guarantee that the application server is always running. Users will be kicked out of an application server in case of a failure event. But Link, as the same as SAP, recommends to have at least two application services running in two different availability zones to ensure that always one application service will be running, and also that users kicked out from a failed instance will be able to connect fast to the secondary instance. The database. In the database, we will see all these things in more detail in the central services scenario, but we will deploy a monitoring toolset that will be monitoring both instances health, the active database and the passive database, And in the event of a failure, the monitoring toolset will detect that failure and it will inform the maintenance toolset to perform the database failover. Now, what about the central services? I will try to explain in more detail this part. Think about in a scenario where the central services are running on the first node that is running in different availabilities on the secondary one. The log table is being replicated from the primary to the standby central services, as any other SAP server will be doing. And the message server is stopped in the secondary central services. A monitoring toolset will be checking every minute. This can be changed by default, it's 1 minute. We'll be checking the health instead, the status health of the active ACS, and also that the replication is alive, and the queue replication server in the passive central services is also running. Again, in the event of a failure, if the primary central services fail, the monitor toolset will notify both the user that something has happened and the maintenance toolset to perform the failover. And this second toolset, based on Lambda function, AWS Systems Manager, and Simple Notification Service, will be able to start the message servers in the secondary central services instance. It will wait until the replication table, the log table in the passive instance is completely replicated to the new message server. And once this has happened, the secondary node will be stopped. The queue replication server will be stopped. Finally, once we ensure that the service has been recovered to the users, and the central services is running correctly in the secondary node, a third toolset, again, based on Lambda functions, Systems Manager, and also CloudWatch, will be trying to heal the failed instances, trying to start the message server again, the instance and the services again. In case that this can happen, the process will ensure that the message server is not started in the passive node, in the new passive node, not to affect the primary one. The queue replication will be started again, and the queue log will be resumed. In case that the secondary, the failed instance is not the heal toolset, sorry, is not able to start the failed instance, it will use an AMI, an image of the previous version, to try to create a new passive central services and try to start it again. In case that no heal action can be taken in this instance, the user will be informed that there are some manual tasks to be performed. And finally, the monitoring toolset will be also resumed, and it will start checking the new primary central service, and the queue replication it has been resumed. And now it's time for the demo. I will review with my colleague Mauricio, so please.
Hello, hello everybody. I'm Mauri from Linke, and I'm going to show you how this toolset works with performing a failover of a central service instance and checking how the system behaves after the failover. So I'm going to share my screen. I'm sharing my screen now. So this is what we have. We have a landscape here with a few SAP instances. We have 2 databases, 2 central instances, and 2 application servers for the complete landscape of the system. And today we're gonna show you how to gonna fail over the central services. For that, I'm gonna shut down the active instance and see how the system behaves. First of all, I'm gonna log into the SAP application server. This way we can check a few transactions about how the system behaves before and after the failover. So I'm going to create one enqueue log. For example, editing one user, that will create a log in the SM212 transaction. Here is my log. The log should not disappear when performing the failover. That will show that the enqueue replication is well done and the failover it's performed okay. Also, I'm going to manage the license transaction to see how the license moves from one central service instance to the other. Now it's active on the primary central instance server, so we can do it here, and the other is inactive because it's waiting. It's not active. We're also going to check the application server logs. We have here the dispatcher. We can see that the application server is connected to the central instance, and also we can check that we can monitor the log table, and we can see that the log table is replicating. The replication is active. So what I'm going to do right now is shut down one instance, and the system should recover itself. I will shut down the system. Now, if we check the logs, we immediately see that the application server has lost connection to the message server. So at this moment, the users will get stuck. We will have no license. We see all white here, so there's no active license at this moment. If we go to the log list, we can see that the system gets stuck and we're waiting. And now the failover software is checking the central instance and performing some checks to see if it's needed to perform the failover. So we have to wait approximately 1 minute, 1.5 minutes or 2, and the instance should recover itself. Now we can see that we have received a mail with informing about the fail of the central instance. That means that the software will perform the failover right now because it has confirmed that the primary instance is down. And now we can see that application server has reconnected. So the performance has been done. The failover has been done. We received a mail that the central instance is okay. So we can see that the hardware key has moved from the primary to the secondary instance. And also we have to check if the log is still there. we refresh, the log is still there, so that means that the in-keyword replication table has been transferred from one instance to the other. So that's all, and now we're going to try to, as we perform the stop manual, we're going to start the primary instance again, so we can fill back to the primary instance. At the moment when the instance boots up, the software will check if really exists, the central services are running, and if they are running, it's going to start the in-keyword replication server. And in case it's not working, we'll start the central service instance, the message and the in-keyword server. So we're gonna connect. We have to connect now to the instance to check if the in-keyword replication is working again on the node, on the primary node. Not ready. So now we're going to the work directory of the in-keyword replication instance, and now we're going to check if it's replicating again. Now we can see that it's connected, so we can do the feedback again. And this time we're gonna do the feedback manually, so we have to launch a lambda function that will get back the feedback the services to the primary instance. This lambda function used to be called by the software, but now we're gonna launch it manually, so that this way we're gonna perform the feedback manually. This function is doing some job, so it lasts maybe 30 seconds or 40 seconds to run. Now we receive another mail about the instance is back again to the primary node. So we're back on the primary node with the license, and we have to check out the logs again, and the log is still here. So we have failover and fail back to the instance.
Okay, so thank you, Mauri, for the demo. So we're gonna wrap up. So if any of you wants to have more details and know more about this solution, just feel free to contact us and reach us, and we'll gladly help you with your deployments in AWS. Of course, the presentation will be available to all of you. Of course, you can check our webinar channel where we have already 3 webinars talking about different ways to optimize SAP workloads on AWS. So feel free to check our webinar channel. And now it's time for questions that from the audience that you might have. So we're going to have a few minutes and wait for any of your questions, and we will gladly answer those. So feel free to use the BrightTalk application to send us the questions you might have. We see, looks like we have no questions so far. I'd like to wrap up a little bit and do a small recap of what we've seen so far in the webinar. We've covered the different SAP application layers and how high availability can be achieved for all of those layers, being database, application server, central service assistance, or network connectivity. And we focused on the central services instance for the demo in order to show how we can achieve the high availability and failover scenario for both, well, based on AWS services. Okay, so looks like we have some questions. First, we have a question from a user saying, can you share screen recording after the meeting? The answer is yes. The webinar is free to access to anyone through the BrightTalk platform, so you will be able to see the recording of the whole webinar and the screen share we did during all the session. We have another question here from Ayush to know. No. Well, the question is if we have used any third-party software for failover. The answer is no. That's actually the key thing about our HA solution is that only with AWS Lambda, SNS, SSM, and CloudWatch we managed to do a full orchestration of the failover and failback of SAP instances without any additional third-party software and any additional license costs whatsoever. We have another question saying, how long does it take for the whole failover process? At the moment, it takes around 2 minutes, but that's because the setup of the Lambda function is scheduled at that time. If you have a more restricted time slots, you can reduce that, and you have more activity on the Lambda functions, and of course a higher cost on the Lambda.
Sorry to interrupt. The failover process takes about 30 to 40 seconds, but the process takes 2 minutes because it has to detect the failure and to avoid any false positives. So we ensure that the failure has really happened, and we are not moving the central services without any reason.
Okay. Next question we have here: if this is transparent to the users, the answer is yes. As only the application service instances is doing the failover, it is transparent for the users in terms that users don't lose their session and they're still logged into the system. But as you could see in the screenshots we share, while failover is happening, the log table remains blocked, and users cannot move forward on the applications. They are not kicked out of SAP, but they are experiencing some small blocking situation during the failover. But that is something that unlocks itself really fast. Okay. Another question we have here is if we are deploying SAP as stateful containers in AWS. The answer is no. We are using EC2 and standard deployment on EC2 instances, and we are not using containers for that. Let's see, we have questions. I see on the question, is there any cost involved in Lambda? Well, the answer is yes, but you have to bear in mind that Lambda has a free tier of 1 million calls per month. And unless you are extensively using Lambda for other purposes, just for HA, high availability of your SAP systems, we estimate the cost to be near to $0 per month. Okay. We have another question about if there is any third-party software used for failover. Again, the answer is no. We are not using any third-party software to do failover, and we're doing everything based on AWS services. Okay, then we have another questions. How do you keep the sync between the HANA databases in the two AZs? Do you use any third-party software, or is all done with AWS tool? Well, the sync between both HANA databases is done using HANA replication, active replication standard configuration. So we are using SAP HANA tools in order to achieve the replication between both databases. So no extra cost on licenses and no extra software to be installed. It's just standard functionality provided by SAP HANA. Another question we have is, please also tell us if you install ASCS and RS in both of the nodes, right? Yes, of course. Both of the EC2 instances having the central services instances have the central services instance installed and the NQ replication server as well installed in order to be able to do the replication between both. Another question we have here is, could HANA database primary and secondary node can take over automatically? Well, the answer is yes. The same procedure we showed you for the central services instances can be set up in order to detect when the primary HANA node is failing and to stop replication on the secondary node and make the secondary node active. On the demo here, we just showed the central services instance orchestration just to make the demo faster, but you can always apply the same procedure to the HANA database layer. Another question here from Ayush. Have you installed ASCS and ERS in both of the nodes, right? Yes, we have installed that. So that means total 4 installation for these 2 single point of failures. Yes, but that's a standard SAP installation in high availability mode. Actually, we need to install all those components in order to be able to have enough redundancy and capacity to respond to the high availability. Another question, what is the implementation time you need to deploy this as a POC? We'll say that in order to do a demo and show that if we are installing a new SAP system from scratch on AWS, it might take us maybe half a day to have all that set up for you and do a small POC on a vanilla installation of an SAP Business Suite application. Okay, if you are already having an SAP installation and we just need to set up the orchestration of the high availability, it might take maybe 1 or 2 days to analyze what you have, adapt the scripts and the code to your installation, or install or add the missing components that you might have for the high availability. But in any case, it shouldn't take more than 1 or 2 days of work to set up a POC. Another question here is, our solution SAP certified, or will support happen through SAP OSS? That at the moment it's not SAP certified, but we are establishing now communication with SAP in order to get that certified in the following months. Another question we have is if we have already implemented this solution for one of our clients. The answer is yes. We have more than one client running in production with this solution and achieving high availability, and it has proven to be working very, very well. Okay. Another question. Well, again, so you mean we have to perform 2 installations for ASCS as well as 2 installations for ERS, right? Yes. You need to install the application, the central services instance in both EC2 nodes and the queue replication server in both EC2 instances. That's right. Another question is, can you share some information if SAP application and SAP HANA are running on stateful stateless containers or in virtual machines in AWS? All SAP applications are running on EC2 virtual machines on AWS. We are not using containers at all. Okay. And another question we have here is from Ayus again. Well, when I was deploying, we had issues that after failover to node 2, the application was not able to access SAP MNC mount. How to manage that folder? Well, short answer here is that the recommended deployment on AWS for sub-mount is to use Elastic File System, AWS EFS, so that you can move that between the different EC2 instances. Okay. Okay. So I think we have no more questions. So we're going to wait a couple of 1 more minute to see if we have more questions here. Okay. Okay, we have another question. What is the cost to purchase these solutions? Can you provide us an estimate? At the moment, the cost might vary depending on the installation and the support required by each customer. So we encourage us to reach us, and we will gladly do a quotation and an estimation based on your specific requirements. Okay, so looks like we have no more questions. We had quite many questions, so hopefully you enjoyed the webinar as much as we did. So thank you very much for joining us today. We look forward to listen to you as well to reach you again in the following webinars. And feel free to reach us if you have any questions or you need more information from us. From here, Mauricio, Guillermo, and myself, we'd like to thank you, and thank you for your time, and hope to see you soon again. Thank you. Bye-bye.